very last meeting for this week. This is week 4. Week 4. And week 4 is on. Finished. 1 week closer to your examinations. I don't mean to scare you, but it's just the truth. And so let's see as much as we can cover for today. Let me know if you can see my screen. The last thing that we was on, anyone can remember that I said we're gonna continue. The last thing.
Probability.
The probability
Probability.
increase.
Yeah, probability. Alright, so the last thing we was on probability. We started very simple, with a simple definition of probability. And then I told you all that we have to move forward and progress, right? So tonight we're going to consider those things. Okay, so where should I begin? Um, we're gonna do some exercises just to orient ourselves, all right, with how it could, the different examples that could happen, and then we'll progress into more um, into more difficult, I would say, but not really difficult, because nothing you do in the BJC or BGCSE is really difficult. It's just practice and stuff. So let's start from the very basic, elementary stuff. The probability on coins. So we're gonna do some examples with those, and then we're gonna continue. All right. So this one says a fair coin is tossed. So there's a reason why it's a fair coin. Anyone could remind me from yesterday why it has to be a fair coin?
Because you
Fair
get a
coin.
50%, 50-50 chance of getting a heads or tails.
Yeah, so you don't want no bias, right? So a fair coin means that there's an equal opportunity for um, either side to be chosen. All right. And so the question says find all possible outcomes. Now, all possible outcomes, let me just kind of put it here. When they say, sorry, one moment. Anyone know what this is? Oh, the answer's right there. Wow. But anyone know what that is? Can you identify what that is? This. Yeah, that's a villi.
All the test sign.
The villi,
Yeah.
the capillary, the villi.
They're responsible for absorption of nutrients. At any rate, so here they're asking for all possible outcomes. When you see all possible outcomes, so this is the definition. So all possible outcomes is called the sample space. Okay, so sample space equals all possible outcomes of the experiment.
Quick question, we're writing that?
Yeah, write that down, please. Write that down. It's a very important definition. What do we mean by sample space? So sample space is going to be all possible outcomes of the experiment, right? Everything and any day when you deal with probability, your answers are going to come in part, from the sample space, right? So you're considering here they're asking us what is all the possible outcomes that could happen if you have a fair coin. And here the sample space is very small. And what's important to understand too is that the sample space is actually a set, right? That's why we did sets before this. I think sets that, or I think I should say, that's why it's good that we did sets before this, because the sample space is really a set, right? It's a set that contains all the possible outcomes that could possibly happen or that could possibly occur. So now the question states find all possible outcomes if a fair coin is tossed. Now because it is a set, how are we going to start it off? A sample space is a set. How are we going to start it off?
With two circles intersecting.
No, curly brackets. Um, we could have a possibility of having a head, right? Or the next possibility is that we could have a tail, okay? And so that's our sample space. So S, capital S, denoting sample space, is equal to head or tail. So if we have the experiment, so this is the experiment now. All right, this is the experiment. Remember, the experiment, it has to be a random experiment, meaning we don't know the end from the beginning. We just know one of the options is going to happen, but we don't know which option it is. And so the sample space is going to be all the possible outcomes. So head and tail. If a fair coin is tossed, and I should add, it's tossed once. All right. Okay, so that's that. So several key terms. We need to know what we mean by experiment. All right. Again, like the experiment is the procedure that happens, but it has a randomness to it. Right. We don't know what's going to happen at the end. And then sample space is another key term. That is to say, list all the possible outcomes, all the possible things that could possibly happen in that experiment. Okay, so someone is still asking. Okay, so we have that. The next thing that we need is, so let's go back to the question. So we already know the sample space. Now the question is, find the probability of showing head. All right. So the probability of head. Okay, the probability of head. Write this down for me. We could write capital H for
Can
head.
you show the previous? Can you do this now so I can take a picture of you?
Okay, no problem. Thanks for asking me. Alright, so let's go back. So again, key terminology is, you need to know what an experiment is. That's the procedure that takes place that has a random element in it. You need to know what a sample space is. That's all possible outcomes.
Can you
Okay?
read the definition of experiment?
Okay, write the definition of experiment. Okay. Alright, no problem. I mean, we come into the formal definitions of these things, but this is talking through it.
I'll wait.
Okay, good. Yeah, we come into the formal definition. Someone is asking to join. Okay, so probability of head. So notice how we write it. It's going to be P, which means probability, open bracket. Probability of head, we use head for H. The probability of getting a head is going to be equal to, or when we toss the coin, it's going to be equal to what it really is. Yeah, 1/2. What it really is. Yeah, 1/2. Yeah, 1/2. Because the formal definition of probability tells us that the probability, and this is for my BGCSE students. So BJC students, you don't have to learn it like this. But for BGCSE students, take a look, right? What a probability of an event really is. So we have an event E, right? The probability of an event E is going to be equal to the number of elements that is in my sample space, right? Total number of elements that are in my sample space divided by, well, all over to what's on top. It's going to be the number of elements that is inside my event. Okay? And so both of these are, remember the notation, this notation comes from set theory, right? The number of elements in my sample space. Remember what the sample space is. We saw the sample space. We said the sample space in the previous one that we just saw. We said the sample space is going to have what inside of it? Heads and tails, right? Right, and so my sample space, remember the number of elements in my sample space is going to be equal to what? The number of elements in my sample space. This is 1 and this is 2. So the number of elements in my sample space is going to be 2. Now we have the event. The event is, this is very important, the event is a subset of the sample space, right? The event is a subset of the sample space. So E is going to be a subset of the sample space. That means that the event is going to be something that happens, or one of the is going to be one of the elements in the sample space, or some of the elements in the sample space. So the event that I get ahead, right? Let's say the event is that I get ahead. That event, right? That's a set, and that event is going to have one element in it, which is head. And so we said that that the top number is going to be the number of elements in the event, right? And so much elements in the event. Just head as 1. And so the top number is going to be 1. Okay? This is the more rigorous way to write it. But for BJC students, we just need to know, okay, this is a half, because, you know, the top number is from the head and the bottom number is from, you know, how much options you have. But this is the rigorous way to say it, that the 2 actually comes from the number of elements in my sample space, and the 1 actually comes from the number of elements that are inside my event. Okay? And so that's the idea here.
Pause with it.
Yes, ma'am?
It'll be the same thing for tail, but just that you
Yeah,
put a
it'll be
T.
it'll be the same thing for tail. So this is number 1, and so number 2. But this is number 2. Wait, this is number 2, right? I think this one is number 2, because we already did number 1 first. This is number 2. Number 3 is going to be for tail, and for number 3 for tail, it's going to be the same thing, a half, because it's going to be, so probability of tail, so use capital T for tail, is going to be equal to
Half.
the number of elements in my sample space, which is still 2,
2.
and the number of elements in my event. This time the event is going to be different. It's going to be the event that I get a tail, right? Alright, and so
Yes, sir.
that event still only has 1 element inside the set. And so that event is that event is a tail. Alright? And so it only has 1 element in the set. Okay? And so therefore we have 1 here. Okay? Okay, so those are pretty straightforward ones. Again, probability of getting a head is a half. Probability of getting a tail is a half. There's an equal opportunity, so 50-50. Alright? Very basic, fundamental things. Okay, can I move the slide?
Yes, sir.
Are you just trying to prove how to write that?
What? How to write what?
For number 3, okay.
Oh, you mean how to write? How I have it all over the place, see?
Yeah.
Yeah, that's my apologies.
Never mind.
So number 3 is the stuff in green. Okay. And number 2 is what I have in red here. Alright, so let's move on. I can move on, right? Be good? We good?
Yes, sir.
Okay. Alright, so someone's asking to be let in. Okay, I need to write it. Alright, so we still have. So find the probability of showing a tail as a half. Find the probability of showing I like. Okay, this is why it's important, and I might as well just do it now, right? This is why it's important to get. Sorry, let's look at. This is why it's important to get the definitions down pat. So let me see if this book does a good. Yeah, this book does a good job at talking about definition. So write this down. So this is the formal definition of an experiment. So an experiment is an occurrence with a result or outcome that is uncertain before the experiment takes place. So when we're talking about probability, we're talking about stuff that we're talking about an experiment, and the outcome is going to be uncertain, right? It's going to be uncertain, okay? So before the experiment takes place, so that's why it has a randomness to it, all right? So when we're talking about probabilities, we're talking about experiments where we have a set of procedure that happens, a situation happens, but the outcome is uncertain, okay? The outcome is uncertain. Now, the set of all possible outcomes is called the sample space for the experiment. So this is the formal definition, okay?
Write that whole thing.
Yeah, write it down. What happened? You write it down. I don't really trust pictures, man. So because pictures, they could get deleted. I remember when I was at university, right? And I always used to like take pictures. And you know what happened? When my phone ran out of space, what I started doing with the pictures?
Delete them.
Start deleting them, right? So, well, this ain't important. This ain't
No,
important.
I wasn't taking a picture. I was asking if you want us to write the whole definition, sent you to give us a definition of sample space.
Oh, okay. All right. If you consider, I think sample space was straightforward. Experiment, yeah, definitely put that formal definition. Okay, so I like how this book breaks it down. They tell you exactly what's happening. So flip a coin and observe the side facing up. That's the experiment. All right. So every time they give you a question, you could break it down into these three things, right? What is the experiment? So you think, okay, what is the experiment? Okay, the experiment is flipping a coin and observing which side face up and down, right? Someone mic is unmuted. Be careful.
That was Zaria.
Zaria, be careful.
Are
Make
we
sure your
gonna
mic
give
is.
a quick example too?
If you want to, this is not necessary because I don't want to take too long. But I just want to go through it with you, all right? Um, if you feel like you need the quick example, that's okay. That's okay. But this really um would help you with terminology. So when we say experiment, we're talking about something that is uncertain. It has outcomes. There's randomness to it. So if the experiment is you flipping a coin and observing the side facing up, the outcomes is going to be the head and the tail. That's the outcomes that you have when you flip a coin. The sample space is the set. So the sample space is not merely the outcomes, right? The sample space is the set of outcomes. You see what I'm saying? All right. So you put them in the group. Now, another experiment is that selecting a student in your class. Right? And let's assume that you're doing this randomly. So you either closing your eyes or you're doing a raffle, whatever. So there is some randomness in you selecting a student in your class. The outcomes are going to be the individual students in your class, say John, Jake, whoever. And the sample space is going to be the set of students in your class. So that's going to be you putting them in the group. You put in the curly brackets and putting who is there. Okay. All right. So let's see if they have any good example. Okay, they continue with some more examples. Um, so this is another one. So another experiment could be that you select a student in your class and observe the color of his or her hair. So that's an experiment. Okay. The outcomes is when you um, when you select the students, you look at this person here, and one is red, another one is brown, another one is blonde, green, or whatever, right? And you want to do it in a way that has some randomness to it. okay, that could truly make an experiment. And so the outcomes is going to be the colors of hair. The sample space is going to be red, black, brown, or green. Okay, this one is this experiment. The fourth one is casting a die. That's another word for what?
Dice.
A dice, yeah. So when they say casting a die, they mean casting. If you throw a dice, you observe the numbers facing up, and this is one that is typical. And so the outcomes are gonna be the 1, 2, 3, 4, 5 up to 6, because there's only 6 faces on the die, and the sample space is going to be um, that group of outcomes. Okay. I want us to do number 5 together. All right, number 5 together. So we want to cast two two distinguishable dice. That's the experiment. So we're gonna break that down. Experiment, outcomes, and then sample space. Okay. So if you're casting two distinguishable dice, when we say distinguishable, what does that mean?
You could tell the difference between the two.
You could
You
tell
can
the
tell the
difference
difference.
between them.
Yeah, you can tell the difference between them, right? So this is two distinguishable dies, and so we want to create um, a sample space that will tell us all the possible outcomes. So we know the experiment. I want us to construct the sample space, okay? Um, and they give us the outcomes. They tell us it's 36 outcomes. Let's see if that's true. Okay, so let's construct the sample space. So we're going to construct a sample space for the experiment of what? Casting two
Two
distinguishable dice.
distinguishable dice.
Yeah. Okay, so let's do this. So we are going to construct the sample space. Remember, the sample space is a set, so we need to get the curly brackets going. All right. So let's begin with the first thing that could happen. Well, what could happen immediately is that, sorry, let me erase this. So this is what could happen immediately is that for the first one, you could get for the first die, the first number that could come out is a 1. And then for the second die, the next number that could come out is a 1. All right? That could happen. You agree, right? That could happen.
Wait, hold on. Oh, never mind. It's two dice.
It's 2 dice. And you could tell the difference between them. A next thing that could happen is that the first dice could give a 1, but the next dice could give a
Two.
2. Yeah. The next thing that could happen is that the first dice could give a 1, but the next dice could give a 3.
Three.
The next thing that could happen is that the first dice could give a 1, the next dice could give a 4. The first dice could give a 1, the next one could give a 5. The first dice could give a 1, and the next one could give a 6. Okay? And then we go on to the next one. So the first dice could give a 2, and the next dice could give a 1. The first dice could give a 2, and the next dice could give a 2.
Oh, so are
The
you
first
definitely
dice.
beating this operation 6 times?
Oh, yes, we beaten it 6 times. So
And it is 6 times 6, 36.
exactly. So the first dice could give you 2, and the next dice could give you 3. The first dice could give you 2, and the next dice could give you 4. The first dice could give you 2, and the next dice could give you 5. The first dice could give you 2, and the next dice could give you 6. Next up is the first dice could give you 3, and the next dice could give you 1. The first dice could give you 3, and the next dice could give you 2. The first dice could give you 3, and the next dice could give you 3. The first dice could give you 3, and the next dice could give you 4. The first dice could give you 3, the next dice could give you 5. The first dice could give you 3, the next dice could give you 6. The first dice could give you 4, the next dice could give you 1. So we list in all possible outcomes. All right. The first dice could give you The first size could give you 4. The next size could give you 2. The first size could give you 4. The next size could give you 3. The first size could give you 4. The next size could give you 4. The first size could give you 4. The next size could give you 5. The first size could give you 4. The next size could give you 6. Now on to 5. The first size could give you 5. The next size could give you 1. The first size could give you 5. The next size could give you 2. The first one gives you 5. The next one gives you 3. The first one gives you 5. The next one gives you 4. The first one gives you 5. The next one gives you 5. The first one gives you 5. The next one gives you 6. Then last but not least, the first one will give you 6. The next one gives you 1. The first one will give you 6. The next one will give you 2. The first one will give you 6. The next one will give you 3. The first one will give you 6. The next one will give you 4. The first one will give you 6. The next one will give you 5. And the first one will give you 6. And the next one will give you 6. Now, before I close this sample space, is there any, if you have 2 dice and you roll in the first one and then the second one, is there any other option that could happen? And that's what you have to ask yourself. Before you close the sample space, you must say, is there any option that is possible? Is there?
No.
No. Okay, so we have to close our sample space. So our sample space contains all possible outcomes. All right, that is possible. All right, so I can move this right. So I want you to keep this sample space in mind because we're going to come back when we do some questions. We're going to come back to the same sample space. Okay, so that we can answer some questions that they'll ask us. So the sample space is very important for us. So let's continue. Okay, so let's see if we did it right. Yes, we did. Okay. Okay, so I think we basically understand what we have when we're talking about sample space. Alright, so the following example introduces a sample space that we'll use in several other examples. What is it talking about? Oh, this is where they introduce the probability tree. But before we get to the probability tree, an event. Very good. So remember we said that an event, good. This is very good. So take this definition down. Given a sample space S, an event is a subset of S. Okay? An event is a subset of S. And what do we mean when we say subset?
A set by itself?
No. So let's say that we have
It's in
this.
another set.
It's within another set. Very
It's
good.
in
So
another set, but it's
A
like
group?
part of
A group?
yeah, it's no, not it's within another set. So let me say, for example, let's do some quick examples on subsets. And what I mean is, let's say we have the set. Say we have this big set, right here, and we call this set A. Excuse me. And we have another set within it, right? We call this set B, right? So we'd say that. So we say that B is a what?
subset of
Subset
A.
of A. Okay. So B is a subset of A. That means that B is within A, right? Because the set B is within the set A. All right. So we say that B is a subset of A. All right. And we write the notation that we use for subset is B is a subset of A. All right. And so when we talk about an event is going to be a subset of your sample space. And that makes sense. That makes so much sense because the sample space contains all possible outcomes. So if we have an event that happens within the experiment, it have to be one of the sample space, one of the one or a group of those in the sample space. You understand the idea? Or I need to explain it again.
Okay,
Yes,
so what
sir.
you're doing with the sample, I mean, with the subset.
What we doing with the subset? We can show you right now.
Okay.
But an event, so let's say there's different events that we could have. Let's say we're dealing with this, right? Remember the experiment is, so let's make this very clear for you. So let's say that the experiment is, so that this experiment is tossing, so let's say the experiment is tossing um, two dice um, uh, with 6 sides, all right? And we're doing it one after the other, okay? So there's order in it, right? So an event in the subspace, right? All right, an event in the subspace could be the event that um, the first number, right? Or the first, yeah, the first number, or we should say, or we could say the first dice shows um, shows the value 1. Okay, so if we have the event that the first dice shows the value 1, right? Wouldn't that be inside this sample space, right? Wouldn't that be
Yes,
inside the
yes,
sample space, right? It would be all of these, right?
yes. So,
You understand what I'm saying? So the
so what
event,
about the second one?
say it again. No, we just in this event, for this event, we're just saying that the event that the first dice shows the value 1. That's our event, all right?
Okay.
That's the event that we chose, okay? Um, Another event could be that the event that let's say the the event that the second dice shows an even number. Okay, that could be an event. All right, and if that's an event, where would that be? Would it be inside the sample space?
Yes, so.
Yeah, those ones that have an even number for the second value would be this that have 2 for the second value. This one has 4 for the second value. This one has 6 for the second value. So these would be a part of our event. Okay. Um, this one has 4. This one has 2.
Specific,
Yes, ma'am.
there could be specific, like you could say stuff um, like or a line or number less than 3 or something like that.
Yes, that's another event. Okay. So let me erase all ink. So another event could be, but the only idea I'm trying to get at this point is that the event is within the sample space. You all get that idea? That's the only idea that I
Yes,
want to really bring out. That the event, whatever the event is, it's gonna come right from the sample space. Is that clear for everyone? Let me know before we
It was clear the
continue.
first time.
Okay, that's good. So the event is going to be something that, and it's going to be a set that is a subset of the sample space. Okay.
Oh, you
So
almost confused me with all these examples.
crazy. The
Yeah,
examples.
let
Hey, everyone don't learn the same. All right. And so we have to give as much examples as we can to, and the examples are going to become important. Um, right as we move on. The outcomes E are called favorable outcomes. That's another important terminology that we use. Favorable. We say it's favorable because that's what we want. That's the ones that we selected. All right. And we say that E occurs in a particular experiment. We said that the event occurs in the experiment if the outcome of the experiment is one of the elements of E, that is, the outcome of the experiment is favorable. We say that E occurs in a particular experiment if the outcome of that experiment is one of the elements of E. Yeah, that's pretty straightforward. That's just basically saying exactly what we said. Okay, so the sample space is going to be S. The event is going to be a subset of the sample space. Okay, so now we're ready to... Okay, this is just giving us a visual.
This book looks familiar.
You have it?
I think I was using it. That's where I get them Pascal numbers from.
Okay, this is a very good book.
It's,
Very
the
good.
book start off with like in inductive reasoning and stuff.
No, 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 no.
Okay, different book.
Uh-uh. Okay, so visualizing an event. So we say that if this is the entire sample space, if the box is the sample space, then the event is going to be a part of the entire sample space. Okay, and so they are basically they're going to give us some examples of an event. Okay, and so here we have the experiment rolling a die, and an event is going to be the number observed is odd. And so the event is going to be 1, 3, and 5 because that's the odd numbers that we have. The experiment here, if we roll 2 distinguishable dice and observe the numbers facing up, if we have an event F, we call the event F, and it is the dice shows the same number. Okay, that's the event, that the dice shows the same number. Then that event is going to be consisted of 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Okay. If we roll 2 distinguishable dice and observe the numbers, that's the experiment. Let's say that the event, we call the event G, that the sum of the numbers is odd. Sorry, the sum of the numbers is 1. That can't happen because there's no way where in the sample space, let's go back here, it's no way that the sum of the numbers could be 1, because if you add 1 and 1, you get 2. And if you add 1 and 2, you get 3, and so on. So there's no way you could get where the sum of the numbers is going to be 1. It just can't happen. So that'll be empty set. Okay, so now that we know what is a event, and now that we know what is a sample space, we are ready, I would say, for
Wait, but you have
the definition. Go ahead.
where they get an empty set from?
It's empty set because, sorry, it's not empty set, it's 0. The probability is going to be 0. But the G is going to be empty because there's no numbers that's going to be where there's no number. Let's look at our sample space. Which one of these have where you add the numbers is going to be 0? It's going to be 1. If you add 1 and 1, it's 2. If you add 1 and 2, it's 3. If you add 1 and 3, it's 4. So the event that we have the numbers being equal to the sum of the numbers being 1, that event is going to be equal to the null set or the empty set, because that can't happen. Okay. All right. So with that in mind, let's continue. These are saying the same thing. Now we are ready to this event. Roll the die. Okay, they're just describing more events and the sample space and stuff. I want them to give the complement of event. This is also important, but I'm not going to consider this right now. Union of an event. This is also important, but I don't want to touch this now. What I really want is for them to give the definition. Mutually exclusive, no. Definition. Oh, they ain't touch probability yet. They're just talking about sample spaces. Okay. Alright. Relative frequency. Okay, so here is where they try to, you know, try to describe probability from a practical aspect, and then this is where they give a theoretical definition of it. Alright. Alright, so that's the definition that I want them to give, and then we could do some examples on that. Okay, there we go. So this is the example that we need to remember. So the probability of an event, like I told you before, this is the example that we are going to work with for all of the questions that come after. The probability of an event is going to be equal to the number of favorable outcomes, or the number of elements inside the event, divided by the total number of outcomes, right? Or the number of elements in the sample space. Okay, so this is the definition that I was looking for.
What definition?
The same one, the one I just highlighted. Okay, so let's use that definition to work out these problems. Okay, so we're gonna begin with this first problem. So determine, this is number 1. So number 1. So I guess we can title this probability exercises. Sorry, probability. Okay. So determine, so 2, let's say 2 distinguishable die, distinguishable, no, yeah, 2 distinguishable die are rolled. Determine the probability that the 2 die show the same number. So determine the probability that they show the same number. So we know that the experiment, so if we were to break it down, we know the experiment is going to be rolling 2 distinguishable die. It's going to be an experiment. The sample space is going to be all of this, what we saw before. So all of this is going to be our sample space. Okay, we saw this before. We're not going to write it again, but all of this is our sample space. So our sample space, we're just going to say look to the previous slide. Now, the number of elements in our sample space is going to be equal to what? Remember we saw the number of elements in our sample space? 36, yeah, from all of these. And so we're good. We're almost halfway there. Now we need to consider the event. So the event, let's call it E. is that the die shows the same number. Okay, that's the event, that we get the same number for both die. And so here we first need to figure out what is the event. But for our sakes, I'm just going to consider the number that is in the number of elements that's in the event, because I don't want to have to write all that. It's just going to be too much to write. I'm not actually writing, so I'm typing. So I'm just going to consider the number of elements in the event. You know what? Let's just do the event first, because that would make more sense. So let's just do it one time. So the event, curly bracket. So the event is set symbol I'm looking for the curly brackets. If you can't find the curly brackets, you have to write it down. There we go. So curly brackets, we need to figure out what's going to go in this event. Remember, the event is going to be that the die shows the same number. And so let's go to our previous slide.
So there could be multiple.
Yeah, it could be multiple things inside this event. So let's do. So you want that the die shows the same number. So what's going to be inside this event? Which
one.
ones? Yeah, 1, 1. So that's 1.
2, 2, 3, 3,
2,
4, 4, 5, 5, 6,
3,
6.
3, 4, 4, 5, 5, and
6,
6,
6.
6. Good.
We still right now.
So let's write the event. So in our event, we're going to have 1, 1. We're going to have 2, 2. We're going to have 3, 3. We're going to have 4, 4. We're going to have 5, 5. And we're going to have 6, 6, 6. Right, so that's going to be what's inside our event. Now the number of elements in the event is going to be how much? Sorry.
6.
It's going to be 1, 2, 3, 4, 5, 6. It's going to be 6. And so therefore the probability of getting the event, capital E, is going to be equal to, remember we said that it's equal to the number of elements that inside the event divided by,
36?
yeah, divided by the number of elements in the sample space. That's going to be equal to 6, because there are 6 elements inside here. This is the first one. This is the second one. This is third, fourth, fifth, sixth. So 6. And the number of elements in our sample space is going to be
36.
36. Okay. And so this is going to be equal to, but it's 6 divided by, remember we always simplify probability. So how much times 6 goes into itself?
Once.
Once. Once. And how much times 6 goes into 36?
6.
6 times. So the probability of the event that's getting a die that shows the same number is going to be 1 over 6. All right. And notice how we used our ideas of event, sample space, number of elements in the set to be able to put everything together. Okay. Any questions for
Okay.
me?
So all of that's what you'd be looking for in the BJC exam?
For BJC, they wouldn't extend it to. I don't see them giving you a sample space that contains 36 elements. The most they'll do for y'all is they'll give you a sample space. Like, let me do one. Let me do one.
Mr. Petit,
Yes, sir.
are the E means elements, right? Element, right?
The E, this
E by
E,
itself. Yeah.
this E.
Yeah.
I use that E for event, so I'm calling
Okay.
the event E. Okay.
All right.
Before you show your example, okay, you say you have 1, 1, and 2, 2. Why you choose those numbers again?
Okay, because we want the die shows the same number, right?
Okay.
So we have to choose those ones because those are gonna be the options where the die is gonna show the same number. So in this one, your first die shows 1 and the second die shows 1. You see what I'm saying? And so they show
Yes.
in the same number. And here the second die shows 2. Sorry, the first die shows 2. The second die shows 2. You see what I'm saying? So it's showing the same
Okay.
number. The same thing. The first die shows 3 and the second die shows 3. That's why we chose 1, 1, 2, 2, 3, 3. So on.
All right.
Make sense? Alright. Alright, so Miss Cooper asks, how would it be for them? Like I say, they are. Oh, I someone that's not in the. Okay. Alright, so it's a good time to take the attendance. Alright, good. So back to your question, Miss Cooper. For something like y'all, like I say, I don't see them bringing something like this, but this is not far-fetched because this is probability here. But for me personally, I see them doing something more like this for y'all. I see them giving you all something like, so let's move all of this. Let's say that the event. Let's say that the question says that um a die fair dice is rolled. Right? Determine the probability that the dice shows an odd number. Okay, something like that. So what is in this case, what is the sample space?
6.
The sample space, not the number of elements in the sample space.
I mean, from 36.
The sample space is going to be what? 1.
One.
So you can get option from 1. It could be 2. It could be 3. It could be 4. It could be 5.
Five or
And it could
six.
be 6, right? Now, the number of elements in the sample space, like Mr. Bethel said, was
Six.
to be 6. All right. The event is gonna be the event that the dice shows
Rolls on
an
an
odd,
odd number.
yeah. And the probability of that event is gonna be equal to, sorry, probability of that event is gonna be equal to, sorry, let me just use this right now. It's gonna be equal to, let's put this kind of in the same. So the probability of that event is gonna be equal to the number of elements in the event, which is what? Oh, we didn't even describe the event, eh? The event is going to be equal to the ones that are even. Sorry, the ones that are odd.
So it'd
So
be 3.
3 and 5. Oh,
1,
1, 3, and 5.
yeah, 1, 3, and 5.
5.
And so the
So
number
it's
of
like you
elements,
won't give a number, you just put like you list it out then.
the number, we still have to include the number of elements, right?
Oh,
In
okay.
the event, which is what? 3, because this is 1, 2, 3, okay? And the probability of that event is going to be equal to simply what?
3
3
3
over
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 6.
3
3
over
over
6.
6. Yeah, but remember we simplify it, and so it's going to be, how much times 3 goes into itself?
1 time.
That'll be 1 over 2, right?
Yeah, 1
A
over 2.
half.
Yeah. So I see they bringing something more like this for you all.
I mean, it's the same format. I was wondering if it's a
Alright,
different format.
alright.
Can you repeat that?
Say it again?
So you're supposed to simplify it in a fraction. They always want a fraction, right?
Yeah, always simplify it. Always simplify the fraction. Don't leave it unsimplified. Okay?
Can you write it back as 2 or or you have to put it 1 over 2?
Have the right 1 over 2. Can't just put 2.
Right.
Yeah.
I was saying if it's a format for a different format.
A different format? No, I don't see them bringing anything. They just could change they might, instead of using dice, they could use cookies like we saw in the last thing. Instead of using dice, they may use, I saw one time they use oranges and fruits and stuff.
Okay, so I have a question.
Yes, sir.
Would you think that kind of question would be in a BGCSE?
This?
Yeah.
No, that's too small. That's too simple. Something more like what we did with the sample space of 36.
But that
Something
wasn't
more
too
like,
hard for BJC student.
they wouldn't put that. Trust me, they wouldn't put that. I promise you. Because remember, we had to determine the sample space, First, you have to figure what the sample space is, right? And they wouldn't get that. I promise you, they wouldn't get that. Because you have to know what we mean by two distinguishable die, right? That would throw a lot of people off. And you have to know that, okay, you have to put it in as an ordered pair. They wouldn't put that. I don't see them putting that. Nope. Okay, so let's do another example before we move on to another idea. Okay, so all right, so
The only
let's
thing
say
that's the problem, Mr. B,
what?
that the BJC that easy. So they ain't want to really make a big jump
The only
from BJC to
calculation.
BGCSE, so that end up like bringing down the BGCSE to
Yeah,
like make a
yeah,
bridge
yeah,
to the BJC.
yeah. That's true. Yep, that's true.
So if the BJC was like more advanced in the first place, then the BGC would be even more advanced.
yeah, that's true. That's true. That is so true. But hey, just look at it like this. That makes it easier for you to pass, right? Or to get an A.
Yeah, government working.
Anyway, to distinguish about the die or rule, um, determine the probability that instead of saying the probability, this is number 3 by the way. Let me change the color so that you can notice it's a different question. So I'm going to change the question, right? So instead of saying determine the probability that two dices show the same number, let's say that determine the probability that the sum of the numbers are greater than 4. Okay. So again, the experiment will still be rolling the two distinguishable die. That would still be the same. Right, so everything here is the same. The sample space, is the sample space still the same?
No, sir.
Anyone else? Is the sample space still the same?
No.
No, the sample space is not the same
Why
still.
would it be different?
Exactly. Why would it be different? We still rolling
Oh,
two.
Jane.
Only the event different.
Sorry, I thought you mean the element. I looking at events.
The event, the you say only the event is different, but the experiment is the same.
Yeah, sorry, I was
Yeah.
looking at the event, thinking
Uh,
why look like that. Sorry.
okay. So the event is the same. That we still dealing with the same experiment. So the sample space and the event is the same. So that means that the number of elements in our sample space will still be 36. That's okay. But the event changes. So this is the die. The sum is greater than 4. Alright, so that means that we have to change some things, and now the sum is greater than 4. Okay, and so let's go back to our sample space, and we have to include only the ones that are only where the sum is greater than 4. So let's do that. So 1 ain't cutting it because 1 plus 1 is 2. We have to look for where the sum is greater than 4. So we could start.
Only greater, right? Not greater.
I think
Equal
No,
to.
not greater. Only greater than 4. Yeah. So we could choose this immediately, right? Because 1 and 4 is 5. We can choose this.
So typically there's that 3 times 6.
Say it again. 3 times 6. Yeah.
Yeah.
Well, no, 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 no.
No, no, no.
It'll increase with the numbers that we add. So 1 and 6
Okay.
is 7. Um. So 2 and 2 is 4. So we have to go here with 2 and 3 is 5. 2 and 4 is 6. 2 and 5 is 7. And 2 and 6 is 8. So that'll be that. And then here is going to be 3 and 2. 3 and 3. 3 and 4. 3 and 5, which is 8. 3 and 6. Right? And then for this one, it's going to be 4 and 1, which is 5. 4 and 2, which is 6. 4 and 2, which is 7. 4 and 4, which is 8. 4 and 5, which is 9. And 4 and 6, which is 10. And so after that, everything else is all this is included. Do we agree?
Yes, sir.
I
Because
agree.
all these would be greater than
Oh, we
greater
including
than.
the 5 and the 1 too?
Yeah, because 5 plus 1 is 6.
Oh, yeah, yeah.
Right? So we looking for where it's gonna be greater than 4. Any
So
questions?
only 6. Out of the some space sample is not it.
Yeah, only 6 on the sample space. Any questions on how we selected these ordered pairs? Any questions?
No, sir.
I have a question if you could like
No, sir.
just cheat sheet it like you know.
You mean, yeah, it depends on if there's a good recognizable pattern. Like I saw you try to make the pattern with the 3 of these ones. Sometimes it works, sometimes it doesn't. It depends on the question. So um like for example, I can show you one where there's a pattern, where there's an easy pattern that it naturally flows. um I'll show you one. But sometimes
So
there is a pattern and
majority of the
sometimes there's not a
time we
pattern.
have to like list it
Say it
so there's
again.
no.
Say it
So
again.
like majority of the time we have to list it.
Yeah, so you have to count it. You don't have to list it because here I'm not gonna write them again. Right? I'm not gonna write it again. I'm
Yep,
just gonna
these are
count
the
it,
ones.
right? I'm just gonna count it, right?
Mr. Vicky,
So
one question.
go ahead.
Everything that is greater than 4, do we have to rewrite them again?
No, that's what I'm saying. I'm not gonna write it again. Let's just count the numbers in the event, okay? So this will be in the event. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so the number of elements in our event is going to be what?
30.
30. So what this is saying is that the idea is that we're looking for the ones where when we add it, it's greater than 4. So 1 and 4 is 5, so that's greater than 4. And all of these, if you add them, if you want to take the time out and add them, you will see easily that 1 and 5, that's 6, so it's greater than 4. Even for this, 5 and 4, 5 and 4 is 9, that's greater than 4. So we're looking for all the ones that are greater than 4. And we found out that there's 30.
Would they ever ask what's the sum of all the dice rolls?
The sum of all the dice roll, that wouldn't be probability though.
Yeah, I don't know.
Okay, so the number of elements, sorry, the number of elements in our there's a shorthand way to write this event, but I'm not gonna do it. But we're just gonna say that the number of elements in our event is gonna be 30. And so the number of elements in the event is 30. The number of elements in the sample space is 36. What is, can we simplify this?
Yes, sir.
Can we
I
simplify it?
don't think so.
Yes, sir.
Yeah, we can.
Yeah.
Yeah.
Okay, use some multiple. I mean,
Divide by what?
2.
Divide by,
Yeah,
we
that's
could
what I
even divide,
do.
why don't you just divide by 6 one time?
Well, yeah, 6.
And so if you divide by 6, 30 goes into 6 how much times?
5.
5. Very good. Kennedy, it's good to hear your voice.
Uh,
I haven't been hearing you. What been happening for the last hour and 15 minutes?
Notes.
Yeah, that's what they always say.
Come on now, just be honest.
All right. 36 divided by 6 is
6.
6.
6. So the answer is 5 over 6. All right. All right. So
I think
send
this
this to me.
experiment got too much sex in it.
Yeah. So send this to me along with all the other notes that you've been taking thus far. Because Kennedy say she been taking notes. So send the notes thus far that you've been taking. Whatever it is, I just want to see something to know that you're following along with these things. Miss Nixon, you're kind of quiet. Are you okay? I haven't been hearing Miss Nixon. I guess she watched the recording.
You could go like this.
Okay, no
Okay.
problem. Okay, so of course there are other ways that we could do this. I don't want to be the dead dog, but we could consider other probabilities, like the probability that the numbers are greater than 5, or the probability that the numbers are less than 2, or the probability that the first one is odd and the second one is even, and there's a lot of different things that we could do with this very same one question, right?
What's the most difficult probability to find?
The most difficult probability to find.
I don't want
For
most difficult.
Like
Just
when
one
they
easy.
ask you the percentage.
Say it again.
Uh,
For this whole question, don't matter how you switch to have the simple space, will still be the same.
Say it again.
I say for this same question, like no matter how much time you switch it up, like saying less than, greater than, or whatever,
Yeah.
would
Yeah.
the simple space still be the same?
Yeah. The sample space will still be the same because you're still dealing with two distinguishable die that are rolled. So the sample space wouldn't change. Okay, it still remains. Um, still remains.
Miss Petit,
Yes, ma'am.
the first one we did, is that like an example of the BGCSE or
Which
you
first one?
just the
This?
previous one? Yeah.
This?
Mm-hmm.
This is just giving you. I don't know what they're gonna put on the exam, like I say. But this is just formatting you so that whatever comes, they could ill. But this is fair game because it's on the syllabus. Okay, and so it's on the syllabus, so we have to cover it.
No,
Um,
I just was asking because the ones I always encounter are like in the tree form, like the descending tree,
okay,
and
that's
then
the
the
probability
sample
tree.
space.
Yeah, that's So we should do one in the probability tree. Um, that's one that often comes for real. Okay, but like I say, this is foundational work, fair game stuff that they could ask you. Okay,
Why you
This
keep
one
on
looks
giving us
way
cliffhangers?
easier.
say it
This one
again.
look more. This one is easier than the tree, though.
One.
Yeah, I was saying you keep on giving us cliffhangers on this probability tree.
It's the probability. It's nothing hard about a probability
It's like,
tree.
oh, okay, I gotta do this one first. I ain't ready to touch that yet. Like,
I have to. Come on, we have to do found. It's like how can you learn how to walk without creeping? I mean, how does that work? You just wanna walk? It don't work like that. All right.
No, because
And
see,
there's a lot
I
of
don't
and
know where he was getting at, but I was trying to say that why they can't do the one you just did rather than giving us that tree, because that tree is get confusing.
no,
But
it does. Oh my goodness,
And
it
then we
doesn't get.
try to
they could give us this rather than that tree. You know, they don't know they know not to do that.
All right, let's deal with the probability tree since you're so eager to deal with it. It's really simple. Okay. Um. Okay.
is it more simple than what we just did?
Mm, in my opinion,
no.
I don't know. I can't answer off. I don't know.
Okay, so it's so low level that you can't distinguish.
between all right. So I like these stuff. These are good stuff. All this is in the realm of probability. Um. Okay. So let's see. Let's get the probability tree. Let's see if they could give us a question like that. Probability in their models, counting techniques, condition probabilities.
So
Um.
they use this kind of stuff when they trying to calculate if a meteor can hit us or not.
Not. I mean this in principle, but not. Of course, it ain't gonna be as elementary as this, but this in principle. Um. Okay. So
Did they create the tree like to confuse us? Because I know you
no,
can
no,
do
no,
it
no, no, no.
by.
The
Is
tree
it
is not
like
meant to put. Okay, I like this one. This is a good example. Okay, this is a good example. This is a very good example. I like this. Very good example. Okay. All right. This is a good one to use. Okay, so let's deal with example 12. 3. It says an experiment consists of tossing two coins. The first coin is fair, while the second coin is twice as likely to land with heads facing up as it is with tails facing up. Draw a tree to illustrate all possible outcomes and use the multiplication principle to compute the probabilities of all outcomes. Okay. Now with this one here, they what they did for us is that they told us that, hey, you're gonna have to determine what the tree is. Okay. In the BGCSE, and if it comes on the BJC, they usually give you the tree. Okay. Um, and so they would usually give you a tree something like this, and it just would have missing parts to it. That's all. Okay,
Yes,
that's
come
all.
on the BJC.
I haven't seen it before. Coming on the BJC. But the idea is the following. So you start at this experiment. So you start. Remember, the experiment is you're gonna toss two coins. All right. So here we tossing two coins. We're not dealing with die. Right. So you're gonna toss the two coins. Now this one is the options for the first coin. So what they're saying for this one at this first point is that there are two things that could happen. Either you can get a head or you're gonna get a tail. Okay, so that's the idea about this one. Either you're gonna get a head or you're gonna get a tail. So with the probability tree, you put the probabilities on top of the line that you're dealing with. Okay, so you would put it right here. So you'd say, okay, if we start here, the probability of us getting, remember it's a fair coin. I'm sorry, remember it's a coin, at least for the first time. And so if we start here, only two things can happen. Either we get a head or a tail. So the probability of getting a head is going to be a half. And the probability of getting a tail is also going to be a half. So here they're equal. Okay. Now, when we go to the second coin, remember what they tell us about the second coin. They said that the first coin is fair. So that means that we don't have to worry about nothing. The first coin is fair. That means that there are equal opportunities of getting head or tail. But when we take up the second coin to draw it or to flip it, it is twice as likely to land with heads facing up than it is with heads. Sorry, it's twice as likely to land with heads facing up as it is with tails facing up. So you're more likely to get um, a head than you are to get a tail. In fact, you are twice as likely to get a head than you are to get a tail. Okay? Alright, so when they to describe that idea of twice as likely, alright, they say that the probability when it comes to the first one, and for the BGCSE, for those who are taking it, let me show you how they would have it. Let me show you how they would have it. Now, so they would say they would give you parts of it already done and parts of it not done. So they would say, okay, um, let's cover this one. Let's say that uncovered, and they'd say, okay, let's cover this one, and so they cover those two, and they would say, okay, let's cover this. And so what they want you to, what the idea that they want you to know is that you could determine one from the other, and that means that if you know that this is 1 over 2, right? The only other option for this one, because it cannot exceed 1. You know that, right? It can't exceed 1. Okay? So, remember we talked about that yesterday. The probabilities can never exceed 1. So, if you know that this is a half, what must this be? Well, this must also be a half, because it can't be greater than 2. Okay? And it can't be equal to 2, because, well, this is half of it. So, it can't be equal to 2, because if it was equal to 2, then this option would not have happened, because remember we said that if it's equal, if say for example this was 2 over 2, then that means that it's certain that you're gonna get head, but it's not certain that you're gonna get head. It's a 50% chance that you're gonna get ahead. So if it's a 50% chance that you're going to get a head, it's also 50% chance that you're going to get tail. So you know automatically, all you're doing is filling in the, like trying to add up such that you get the denominator. So for this one, you know that this is 2 over 3. So the bottom one must be what? 1 over 3.
1/3.
Yeah.
1/3.
And then for this one, you know that this is 1 over 3. So the probability of
Yeah,
getting the probability of the
that has to
first
be
one is
2
going
over
to be
3.
2 over
Oh,
3.
so all we doing is balancing the like
That's all you're doing.
fractions.
Balancing the fraction. Now,
It's
the
chemistry.
question. Okay, I guess if you related to chemistry. Now, so this is where students usually lose their marks. So, given something like this, they would say so now that we're ready, so the first points you get is from balancing it out, if you want to think about it like that. The next points that you get is from these sort of questions. So they would say, okay, now that you know this, right? They would say, um, determine the probability. So from this, they would say, determine the probability determine the probability that um, the first okay, let's see, what's a good question to get off. Okay, so determine the probability that the same side is um, is shown um, when the two die is not die, but when the two coins are tossed. Okay, and so this is where the little slight complication comes, because how many ways is this possible? So you're trying to figure out the probability that the same side is shown, right? So that could happen in more ways than one. So there's different ways that could happen. So the first way, is that, because remember, all you want is that the same side is shown, right? The first way it's happen is that you could have double head. Okay, that's the first way. So you could have double head. That's the first way. And then the second way is that you could have double what?
Tail.
Double tail. Okay. And so what you have to figure out is you have to figure what is the probability of, I just gonna use D, of double head, right? So double head is gonna be H and then H. Okay, and so what that means is that the probability of getting the first coin is head is what? A half.
1/2.
And because it's probability of getting one thing and the other thing, we multiply it. Okay, and so that's gonna be multiplied by the probability that the second coin is head, which is gonna be what? 2 over 3. And so the answer for this one is 2 times 1 is 2. So then it's going to be 2 times 3 is 6. So that's going to be 2 over 6. So that's the probability of getting
We simplify it.
the double head, right? You don't need to simplify it for now because we're not done. Okay, we still in working phase. Now the probability of getting a double tail is going to be, well, the first one is going to be a half, right? That's when you do the first coin, the probability of getting the first coin is going to be a half. And the probability of getting a second coin tail is going to be what?
2/3.
Not
Oh, one
2/3.
third.
1/3.
1/3. 1/3, right?
Oh.
And so we have 1 times 1, which is going to give us 1. And 2 times 3, which is going to give us 6. Okay? So like I said, there's 2 ways to do it. Either you're going to get a double head, or you're going to get a double tail. And this is the reason why I said I had to do the stuff before this, because had we done the stuff before this, and I was in a rush to this, you would have known that when you have the probability of one thing or the other thing, you add. Okay? The probability of one thing or the next, you're going to add. So we're going to add the 2/6 and the 1/6. So it's going to be 2/6 plus 1/6. And so it's going to be 3/6. And so it's going to be a half. So the probability of getting the same side, right, when the two coins are tossed, is a half.
Why did we add?
We add because it's it's 2 ways. It could either be the first way, which is double head, and both of them would still be on the same side, or the second way, which is double tail, right? And so since it's either or, you must, and that's why I told you, if I were able to show you that when you have the union of probabilities, you add. That's why we add. Okay?
Okay, I try to understand. I find
The
out when
reason
I'm
we
in
add,
school, so I try to understand. Get complicated in the class, honestly.
Hmm.
Uh,
So,
I understand. It's alright.
the only
I
reason
try
we add
to.
is because
mhm.
it's two, right? Out of
So
these two.
yeah, only reason we add is
Right?
because of these two.
So if
Yeah.
it's only one is like if it's the same side ahead, that 2/6, we would just
Would
simply
be
find out be the answer, right?
Yeah, that'll just be final, right? So if it was if they didn't say, they say determine the probability that the same side is shown. So there's 2 ways for the same side to be shown, isn't it? The first
Yes,
way,
sir.
which is double head, and the second, which is double tail. There's 2 ways for that to happen. And so since there's 2 ways for that to happen, the addition principle, right? The principle of addition tells us that when you have 2 ways, right, to do things, the total number of ways, I shouldn't say two ways, when you could do something in one way and another thing in another way, the sum of the ways is going to be, you're going to add them to get the total amount of ways. All right. And so that's why we add those 2 probabilities. Okay. So here, because it's one way or the other, and that or is very important, one way or the other, you're going to add the probabilities. Okay. But here we multiply the probabilities, because it is one thing and the other thing. So it's heads and another heads. It's not head or another head. It's head and another head. So for and you multiply, and then for or you add. So for and you're gonna multiply, and then for or you add. Okay, that's the idea. Okay, any questions before I move on?
But if they ask for the
Opposite of what?
opposite of the same side, what if they both have to be different?
Okay, so if they ask for the opposite, so let's say they ask for um let's say they ask for head and tail, okay, or tail and head. In that case, you would say, okay, the first one is head, the second one is tail, and so you would multiply those probabilities. In fact, they did it, right? They did it right there. They said probability of head first, then tail is going to be what? A half,
A half
then
times
1 over 3.
1/3.
Yeah, if you 1 over 6. And the probability of getting a tail and then a head is going to be a half times the 2 over 3, which give us 1/3. So if I ask you what's the probability of getting opposite, not opposite, what's the probability that the two coins show opposite sides? What you're going to do is that you're going to have to add this one, this probability, to this probability. You're going to have to add them. Because it could happen such that the first one is head, then the second one is tail. Or the first one is tail, and the second one is head. So you have to add these two. Any questions for me?
Miss Pretty, can you like
Where they
just
get the 1/3
explain
from?
that one like just one more time? I just
Say it again.
could you like explain that slowly one more time?
Which part?
This part right here, the part you're on, where you have like the HT and the TH. Could you explain
Okay,
that,
yeah,
please?
so the idea is that he asked what's the probability of remember the first time we did double side, the same side. Okay? But he's saying, okay, well what could happen if we trying to figure out the probability that it's opposite sides, right? So that means that, you know, it's two ways that this could happen. Like the first one could be head, right? And then the second one could be tail, right? That's opposite, right? And so what you do, you take the 1 over 2 and then you multiply that by the 1 over 3 to give you 1 over 6. That's one way. You agree?
Yeah, so
Yeah, so Mr. Petit, that's how I was
Wait,
trying to
wait,
figure what
wait,
you get
wait.
the.
I mean Nancy, because she asked the question. You agree, Miss Nancy?
Yeah.
Okay. And then the second way that it can happen is that you can have a tail first and then a head, which is still opposite because the tail just come first and then the head. And so in that case, it'll be 1 over 2 multiplied by 2 over 3. That gives you 1 over 3.
also Mr. Petit, the answers they have, they just simplify it beforehand, right? They
Yeah,
just
they just
step by
simplify it.
step simplify it.
Yeah, they just simplify it. Yeah. And so if we're trying to figure out the total, right? We're trying to figure out the total. So we're trying to figure out what is the probability that it's going to be opposite in all. So that means that it could be head over tail. So it could be head tail, or 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 it could be tail head. And so we must
So
add
yeah.
these two. Yeah, so we're gonna add these two probabilities to get the answer that we want looking for.
Okay, and okay, I think I got it now. Just one, this is the last question, right?
Go ahead.
So the numbers, we don't have to figure these out, right? They're just gonna give us these numbers and
Yeah,
we
they
get
give you it.
balancing from there.
Yeah, they give you it. So
Oh,
you don't have the. So like I told you, um like I told you. So here we had to balance it. So it'll be something like this where you have to where they give you some, but you have to balance out the rest. See what I'm saying? Like if this is 1 over 2, you need to know that this is gonna be 1 over 2. If this is 2 over 3, then you need to know that this is gonna be 1 over 3. And if this is 1 over 3, then you need to know that this is gonna be 2 over 3. You understand?
and this is where the one is applied, whereas you only it's not gonna be higher than one.
Exactly. It's not gonna be higher than 1.
Oh,
So you
so
can't be. Go ahead.
no, I just want to figure out when I used to do it, where like how I used to do it. I used to add numbers, thinking it you could have been hiding one. That's why I'm trying to figure out where did I go wrong, and I understand. So
Yeah, it can't be
it's
greater than
just
one.
like it can't be greater than one. So
Yeah,
understand.
yeah, that's good. All right, so that's it. Okay, so this is a appetizer on you know probability trees. Um, let's go back to the fundamentals that we should have covered before getting to this. And the idea is that um, with probabilities you could have intersection, and with probabilities you could have unions, and that's the notion between. That's why we add sometimes and we multiply sometimes. Okay, and so this will we have to explain here in a short bit of time that we have left over. Okay, so um, okay, so the last thing that we
Do
was
those
on.
trees end, by the way?
Yeah, they end because the experiment ends. Okay, so the experiment only consists the experiment that we was on at least it only consists with two actions. First, a first coin and then a second coin, and so it's a finite experiment. It never ends. But we got experiments that it's infinite. Like you could describe your experiment such that it's infinite, like it never ends, and so your probability tree would never stop. Okay, but in this case, and in the ones that they give you, they're gonna give you finite experiments. Okay, all right. Okay, so this is what we talked about, and even this is the exact question you asked: a finite probability distribution, right? So remember we talked about this. This is saying that um, the probability is going to be between 0 and 1. We talked about that. The probability is going to be between 0 and 1. Um, this is, and by the way, these are the axioms of probability. This is what when we come at the rock bottom of what probability is and how we talk about probability from a mathematical standpoint, these are the axioms that we use. All right, and so we say that the probability cannot be greater than 1. That's how we define it. Okay, and we say
You write
that.
this?
Say it again.
Are you writing this?
You don't have to. You don't have to. This is because you don't have to. This we just explaining it. And we say that, and this is very important. The sum of our probabilities is going to be equal to 1. That's an interesting notion too. Like, but it's so true that whatever our whatever our probability is, when we add them all together, they have to equal to 1, right? Which means that each one of them of course there's a probability of them happening, but when we sum up all our probabilities, they must add up to 1. That's why the probability of heads is a half, and then the probability of tails is a half. When you add the two, they must give you 1. Okay, and so that's the idea. And that's why when we have these things, when we have these stuff, when you add 2 over 3 and 1 over 3, you must get what?
1.
Must get 1. And when you add 2 over 3 and 1 over 3, you must get 1. Because when you sum up all the probabilities, you must get 1. Okay, that's the idea. And then we say that if the probability of E is 0, so if the probability of the event is 0, we call it a what? An impossible
Impossible event.
event. All right. The empty event, which we denote as the symbol, is always impossible since something must happen. Okay, so now, all right, now this is a very good example. So what they're saying is that this is a very good example. So um, This is talking about the probability. So let's say we get this one we talked about earlier, Miss what's her name, Miss Cooper. So remember, if we have and this shows you clearly that, hey, the probability of an event, when we talk about the probability and talking about experiments, all of them, when we sum them all up, it must be equal to 1. So let's say, remember, we had the sample space contains these 6 elements. All right, we toss in a die. All right, we toss in a die. And so if we have, like, say, the number 1, if I ask you, okay, what's the probability of getting the number 1, you would easily say that the probability of getting a number 1 is going to be 1 over 6, right? That's clear, right?
Yes, ma'am. I mean, yes,
Yes,
sir.
sir.
Because it's going to be 1 out of the 6, right? And then if we have here, for this one, the probability of getting a 2, well, that's going to be simply 2 over 6, right? But 2 over 6, we could simplify that. That'll be, that'll simply be 1 over what? Sorry, let
3.
me move. So this one is going to be 1 over,
3.
sorry. This, oh, I see what they're doing. They're giving me boxes. Let me move it. Okay, so this one's going to be 1 over 6. All right, the probability of getting a 1 is going to be 1 over 6. The probability of getting a 2 is going to be what? 1 over 6, not 2 over 6, my apologies. Because we're just trying to get the number 2. The probability of getting a 3 over 6 is going to be 1 over 6. Probability of getting a 4 is going to be 1 over 6. And the probability of getting a 5 is going to be 1 over 6. And the probability of getting a 6 is simply going to be 1 over 6 because there's only one 6 in there. And when we toss that die, it's only possible for us to get 1 out of that 6. And so if we add these probabilities, right? If we add these probabilities, you can
So
clearly
why you
see.
keep putting 1?
Say it again.
How come you keep putting 1 instead of like 3?
No, because we don't have 3. If you have a die, okay, you have a dice, right? And you look at your sides that you have. All right, and let's say this is 1. Let's say this is 2. Let's say this is 3. Let's say this is 4. Let's say this is 5 in here. Let's say that the top is 6, right? How much 6 do I have?
1.
I only have 1. That's why it's 1 over 6. You know what I'm saying? I can't say 6 over 6, Miss Cooper. You know what I'm saying? How much 4 do I have? I only have 1 4. So I have to say 1 over 6. You see what I'm saying? But if we add all these together, it's going to be equal to what?
1.
6 over 6, which is equal to 1. And so that's where we get the idea that the sum of our probabilities equals to 1. Okay. All right. Those are good. Probability distributions. Okay. No, we don't want this. We don't need this. All right. What I want us to look at is the probability of intersections. There we go. Probability of intersections, unions, and complements. Okay. So this is a good one. So if there are, so this is the addition principle. Okay. And this explains why we added, okay, those two probabilities before. So if A and B are any two events, then the probability of A union B is going to be equal to, give me one moment, please. Okay, so where were we? Yeah, so we're talking about the union of probabilities, right? And we say that if we look at, let's go where, if we look at the union of probabilities, you're gonna add them if you're determining the union of probabilities. So probability of, so first you determine what's the probability of A, and then you determine what's the probability of B, and then you add them, right? The next thing that you also want to see is that, is there any intersection between them? And if there's an intersection between them, you want to minus out the intersection, all right? And so that's the idea. So remember the first time we was doing this, and I said, and here we had, when we was doing this question, it says find the probability of showing either head or tail. Okay, so that's the probability of showing either head or tail. And so the probability of showing either head or tail, we represent it in the following way. So it's going to be, let's denote the probability of head as probability of P, sorry, probability of H, right? You know what, let's not write that. Let's say the event of getting a head is H, and we have the event of getting a tail, which is T. And so we're trying to get the question is not asking us, this is very important. The question is not asking us what's the probability of head only or what's the probability of tail only. It's say what's the probability of getting either a head or a tail. Okay? And so remember, or is
Union.
union. We saw that, yeah. Or is union. And so what they actually basically asking us is that what's the probability of getting a head or H union T? That's what they're asking us. Probability of H union T. And so the probability of H union T, what's the formula? What's the formula? What does the formula tell us? It's gonna be equal to what? The probability of
The sum.
H, yeah, plus, because remember union means, yeah, union means addition, plus the probability of T, but we got to minus something, right? We got to minus the probability of their intersection. The probability of H intersect T. Okay? Probability of H intersect T. And so that's going to be equal to, what's the probability of H? The probability of getting ahead.
Half.
Half, yeah.
Half.
It's going to be equal to half. What's the probability of getting a tail?
And a half.
And a half. Now, what's the probability of getting a head and a tail?
There's no probability of that.
Yeah, it's impossible. It's impossible because the two events, yeah, the two events are mutually exclusive. So the two events are mutually, sorry. Anyway, that's a U. Mutually exclusive. That means that they cannot happen together. Okay? And so when you have the probability of mutually exclusive events, you don't need to even consider the intersection because you know it's going to be 0. That's why when we added the two, when we was talking about the that's why when we added the two, when we was talking about our probability tree, we didn't even bother considering the intersection because we know it's 0. Okay? So when you're dealing with mutually exclusive events, the intersection is always 0 because they cannot happen together. I mean, how can you get a head and a tail? All right? How can you
If you
be
had
a
two
both of?
points,
Say it again. Now, only if
if
you
you
have,
had two coins, so you
yeah,
would
but
be able to get an intersection, right?
yeah, if you add two coins. But here we only deal, remember the experiment is with one coin, okay? And so that's why it's 0. All right, so this is going to be equal to a half, and a half is going to be equal to a whole, okay? So the probability of the union of two events is going to be equal to their sum minus their intersection. It's not always going to be equal to a whole now. Only in this case, it's equal to a whole.
Now is
But,
in general.
oh, okay, yeah. But in general, we add the two probabilities and then we minus it by the intersection. Okay, so that's the idea.
So what happens if it don't equal to a whole?
Sorry, mutually exclusive events, not mutually exclusively. If it don't equal to a whole, that's no problem because this is just the union of two events.
So if
But
they don't have intersection.
if it don't have an intersection, you still write 0. Now the only way you expect okay, the only way you expect the only way you expect it to be equal to a whole is if you're adding all. You know what I'm saying? If you're adding all your events. So say for example, let's go and let me give you another example. So if we said, so what if I said, right, let's go to this example that we saw before. What if I say I want the probability of we saw this example. What example we had before? The example where we just had it. Okay, yeah, this one. No, not this one. Yeah, this one. Remember we saw that for each one of these, it was 1 over 6. The probability of getting a 1 is 1 over 6. The probability of getting the next one is 1 over 6. And so on, right? What if I say I want the probability, right, of the die falling on a 2 or a 6, right? What would that be? That would be the probability of what? Of, let's call the event that it falls on 2, let's call that event E, right? And let's call the probability, the event that it falls on 6, let's call that event F, right? And so if you want the probability that it lands on 2 or 6, is going to be the probability of the event E that it lands on 2, or, so that's the union, the probability that it lands on 6, which is F, right? And it's going to be equal to the probability that it lands on 2 plus the probability that it lands on what?
6.
6, yeah,
Oh,
Half.
or F, minus their intersection. That the probability that you're gonna land on both F and sorry, that you can land on both. Sorry, minus. So this is supposed to be a minus. Sorry, minus. It's supposed to be minus. Oh my goodness, I didn't just erase it. But let me just do it again. My apologies. So it's gonna be the probability that. Okay, sorry. I just erased that. So let me do it again. It's gonna be the probability that of E union F is going to be the probability of E plus the probability of F minus the probability of their intersection. What's the probability of E? Remember the probability of E is getting a 2, right? E is getting a 2, and then
1
F is
over
getting
6.
a 6. So it's going to be 1 over 6 because it's only one way to get that 2 and it's 6 outcomes, right? 6 possible outcomes, plus for f it's only one way to get that 6 and it's 6 possible outcomes for the dice, and so it's going to be 1 over 6. Now is it ever possible for us to get for the dice to land both on a 2 and a 6?
No, sir.
Not in this
No.
experiment.
No, not in this experiment because it's only experiment with one dice toss, and so it's going to be 2 over 6, and we could simplify 2 over 6 to 1 over 3.
3.
And here it doesn't equal 1, right? And the reason that is because we're not considering all the probabilities. We just took 2. Okay. Now if we're considering the probability of getting a 1 or a 2 or a 3 or a 4 or a 5 or a 6, then that would give us 1. Okay. But the probability of a 2 or a 6 is just going to give us, it's just going to be 1 over 3. Okay. All right.
So if you add up the three one thirds, you would get a whole, right? Because
If you add up,
if two of them is equal to 1/3, then
mhm,
if you add a next two, then that would make a whole, right?
yes, definitely. So if we complete the rest of the probabilities, it will be a whole. Yeah, sure, certainly. All right, so that brings us to the end of math for this week. And so I hopefully you learned something or you revised something. Um, and as we progress throughout this, probability is definitely something that they like to bring on both exams, and I wouldn't be surprised if it come on your exam. It it's like one of those stuff that always come on. They always bring it, and so hopefully, with the little work that we've done in probability, you can get an understanding of how to work some of the problems that come. And as we move along through this course and we do more past papers, you get to see exactly how they would phrase the question or how they would put it. But hopefully, this just gives you a good introductory feel for the idea of probability, and hopefully you get a good framework from which to work upon when it's time for you to do your own.
Mr. Eagle, I get a question on
Go ahead.
math.
Go ahead.
How do you find the percentage of the intersection of two sets?
Okay, so it's not hard at all because first you just have to find the probability. Once you find the probability, it's a fraction. And once you have a fraction, you can always convert a fraction to a percentage. And so that's how you would do it.
Okay.
Yeah. All right. All right. So if there's no more questions for us in math, please send in the math notes that you have, and please send in the math notes that you have already to me. And for those who are staying back for social studies and RK, we'll have social studies first, and then we would have religious. Okay.
Um, yes, Mr. Petit,
Go ahead.
you send a video of this
Yeah,
class
definitely.
session.
This what?
If you could send the recording of this class session, please.
Definitely, definitely. This, along with last night's session, will be sent tomorrow, bright and early tomorrow morning. All right. Okay, so with that being said, have a good night for those who have to leave. The rest of us are for social studies. All right. So for those of us who are staying, thank you for staying. There's about 20 of us. I'm not hearing from you all though. Um, I don't know. I don't know if you're tired for the week or what. But the last thing that we are on from last time is anyone can remember for social studies.
The Lucans.
Yeah, the Lucayans. What were we talking specifically about?
What they do, like when in terms of hunting and gathering.
Yeah, in terms of hunting and gathering, we talked about what they did. We talked about how they used to hunt. What they used to hunt in the water?
Fish.
Fish, yeah.
Turtles.
Turtles, yeah. You know what? Let's do a review exercise. I think we could do a review exercise.
Wait.
I know it's Cooper can't wait. Alright, let's do a review exercise for these. We should have it somewhere in here. Alright. So we're gonna review what we did by doing some multiple choice questions. Um, so bear with me one moment. Let me just grab them for you, and then we can begin with that. All right. I think I found it. Okay, so yeah. So let's begin with this. Let's begin with this one. So this is History 9. So let me share my screen with you all, and then we'll get right into it. And so the first question is the following. Can you all see my screen?
See.
Okay, good. Which was
You
not
didn't
a
even get to
way.
read it.
I thought you were saying see as in Spanish. Like, I asked, can you see my screen? So I thought you were saying
Oh,
see.
I didn't even think of it like that.
Yeah. Alright, which was not a way the Lucayans got their food? Is it A, fishing, B, farming, C, online shopping, D, hunting, or E, gathering?
See.
C, very good.
See.
Online shopping. Alright, good. So they obtain their food in four ways, namely fishing, farming, and hunting and gathering. Which are examples of marine animals that Lucayans went fishing for?
All of the above.
All of the above. Yes, all of the above. They went fishing for fishes, turtles, and seals. Okay, good. Next one is which was not one of the instruments used by the Lucayans to fish? Which was not one of the instruments used by the Lucayans to
Bleach.
fish?
Bleach.
Bleach, yes, bleach.
Bleach.
So they use nets, they use hook and line, they use the remora and spears, but they did not use the bleach. I mean, bleach wasn't even invented yet, right? All right. Bleach, yes. They did not use this bleach. They did not use bleach to catch their fish because bleach wasn't invented yet. All right, next up.
Yeah.
True or false? Crops the Lucayans planted and grew include cassava, maize,
True.
sweet potato, peppers, and herbs.
True.
True.
Just let him finish.
It's true. All
I
right.
mean, we already know this though.
All right. True or false? One of the farming techniques used by the Lucayans is slash and burn.
True.
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 Yeah. Which are examples of animals the Lucayans hunted for?
All of the above.
Alright.
All of the above, yeah.
All of the above.
Yeah. All of the
All
above.
of them.
The next one is which was not one of the instruments used by the Lucayans while hunting?
Guns?
Guns.
Yeah, guns. Guns. Number 8. True or false? By hand or using baskets, the Lucayans gathered the following: shellfish, eggs, berries, and fruit.
True.
That's true. Very
True.
good. Okay, good. We got 100. All right. So let's continue. In the Lucayan society, men and women had the same rules.
False.
False. Yes. All right. Which was not one of the rules of the Lucayan men?
Cleaning the house.
Cleaning the house.
Cleaning
Yes.
the house.
Which was not one of the rules of the Lucayan women?
Hunting.
Yeah.
Hunting. Yeah, hunting. All right. Lucayans made clothing and hammocks from what? Did we do this one yet? We covered this
No.
one?
I think it's
I don't think we covered this yet.
Palm leaves.
You say what?
palm leaves, right?
Palm leaves.
Palm
No,
leaves.
say palm
Yeah,
leaves. No,
What?
I was right.
cotton.
How does make hammocks out of cotton?
Yep, they use cotton to make the hammocks. The part that we use sleep. How they use leaves for that?
Oh. But I thought they used to use palm leaves.
No, that's house.
Oh, I see why she say that.
Right? You mean for the two things, the two structures? I mean, you mean the two trees on the side of it? I mean, but we talking about the stuff that they actually lay on. The part that they lay on, that's cotton.
I was thinking cotton, but then when they say hammocks, I was like, probably palm trees.
What are some of the crafts the Lucayans made?
A? No,
Say it
E,
again.
all of the above.
All of the above.
above.
Yeah, all of the above. Canoes were made by gouging and blank out of the trees. Out of trunks. Canoes were made by gouging and burning out tree trunks.
Yeah, right?
That's a B.
Throwing out tree. All right. So which one you go with? B or A?
B.
Okay.
B.
All right. The answer is A.
Thank you. Thank you.
What?
Thank you.
Yeah.
Thank you. Just want to
Yeah.
let
They
you
burn
know.
out a trunk.
Yes, they did. They did.
That's what they say.
Yes.
Yes.
Is there an oven?
All right. How often would the Arawaks trade with the Tanos? Frequently, occasionally, never, or always.
A.
A.
Yeah.
We're gonna go with A.
Yes.
Not yet. Yeah.
I believe it in a C.
Yeah.
C. Never.
I think it's C.
That's what I say.
Think it's C. All right.
Nah.
Yeah.
See? How is C?
All right, they say C.
Have they ever seen him before?
They said C, Miss Cooper. So
Wow, Miss T, not yet. No, come on.
are we locking in C or what?
No. Okay.
Are we locking in C? All right.
Let them
C
be
is locked in.
I know.
It's occasionally.
Thank you.
Occasionally. All right.
Oh Lord.
That's because we ain't touched. I ain't teach this yet. We're gonna do it today. And then, what did the Lucayans trade with the Thanos for?
Um. D.
All of the above.
See?
I'd
C.
say B.
Okay.
You say B.
It might be C.
Oh,
I
C.
don't know.
Okay, so someone said C. Which one we gonna go with? A, B, or C, or D?
C.
C. Okay, so someone going with C. So it's incorrect.
I said
Oh
D.
God.
Joshua.
Wow. All right. And then that was a lot. We got a 50. Oh, come on. How could we get a 50?
How do you get a 60
Oh
mark?
man.
Because I was letting them do it. They won't be picking the wrong answers.
All right, so let's discuss it. So today's topic is what? Monday, Tuesday, Thursday. So today is Thursday. The, we are in January. No, February. Today's the 3rd of February. I knew that. I just was, you know.
Yeah, I know.
All right, so the subject is social studies. The
I
topic
still
is
gonna write in January.
our crafts, right? We just had the quiz on. So the Lucayans made clothing and hammocks from cotton. We saw that, right? They also made baskets and pottery, necklaces. Sorry, pottery, necklaces, and arm or leg bands. Now, are they similar like us today? Do we also make make and wear necklaces? Do we also wear arm and leg bands, or are we different?
Somewhat.
I mean, yeah.
Some
Yeah,
people do.
Yeah, some people.
yeah, some people wear jewelry, some others don't. Um, but I think that definitely the style of their one is different than ours. Um, anyway, they used stone and axes, knives. That is to make these stuff. Knives, scrapers, and hammers. Now, the other things that they use is they use wood. So everything that they try to use is simple stuff. Nothing technical, nothing fancy. Simple stuff. That's all they had. So they use wood in they use wood, spears and plates. and shells sorry, my apologies. They use wood to make spears, okay, and plates, and they use shells for scrapers or contain or containers. You can imagine having a container that is a shell. That's cool.
I guess it would for them.
I mean, some people still do that today. They still have them decorative um containers
But don't
that
they just like put the shell on the outside? Like they don't really. They like have a bowl and just put the shell on the outside for like decorations.
yeah. Okay, next up is canoes. Canoes, how do they make their canoes? We saw this earlier. Canoes were made by gouging and what? Burning
Burning.
out tree trunks. Right? And how often did they trade with the Thanos?
Occasionally.
They also exactly occasionally, all right, traded with the Tianos for which items?
Uh, um, gold.
For gold,
Axe thing, axe head, and
for gold,
stones.
special stones.
Or an axe head or something like that.
Yeah, special stones and axe heads. Okay. All right, so that's it on our craft. Now I am going to. We're gonna discuss. We're not gonna write the notes today, but I'm gonna give you a preliminary test just to see where you're. Just to see how much you know before we do this for next class. So next class we're gonna be talking about the cacique. We're gonna be talking about the job of the cacique, and we're gonna be talking about where he live and all that stuff. But I want to give you a introductory quiz on that just to see where you are. Hopefully you're not gonna get a 50. All right. Are we good?
You gonna do it right now?
Yeah.
Yes,
Think
sir.
so.
So let's
Miss
move.
Routine, I finished right now. I am the last part.
You
I
ain't
wasn't
finished writing
finished
yet?
yet, sir.
All right.
I was in the last part, sorry.
All right. No problem.
Okay, go.
Okay. All right. So,
I'm not finished yet.
okay, no problem. Who's that speaking? Deshaun?
Yes, sir.
Okay. Very good, Deshaun. I love that you're participating. I wish that more people would participate like you and the others. Okay.
I participate.
Say it again.
I participate.
Yeah, definitely, Miss this what? Avery McDonald, right?
Yes, sir.
Yeah, definitely. Yeah, man. I like when y'all participate. It's very good. Okay, so can we move on? Or we still writing?
I'm still right now. I'm at the last part. Sorry about that.
No problem.
So they traded with the Dinos for gold, special stone, and oxide, but what did they trade them with?
That's a good question. They trade with what they had, so um they wouldn't from at least the book that we're using. They say that they don't trade their food. Um, but they said that they did trade in other items. No, this is talking about what they gave the Thanos, right? Um, and so because they say the same thing back, they say that
What they can
they
return?
they would get. It doesn't seem like it's anything different. They say they trade in other items such as gold pieces, special stones, access, and pottery. And here they say 4 gold, special stones, access, and pottery. So
Guess they trade like the same thing.
I guess maybe for the
Okay,
ones that
I'm
they didn't have,
confirming.
for
I
the
don't
ones that they
remember us looking at the precise, but
yeah, I guess for the ones that they didn't have, that's a good question. I'll have to look into that. I'm not sure. I guess for the ones that they didn't have, um, all right. So let's move on. We have about 1 minute left before we go to RK.
we
But
ready. We
let's
ready.
begin with this. It's introductory one before we move on to the before we do it for next class. It's what was the Lucayan ruler called? Is it the prime
D.
minister, the
D.
governor, or the
D.
cacique? D, definitely
D.
the cacique.
That's
D.
D.
Very deep.
G. D.
D, yeah. Okay, so we got one right. The cacique rules over a village or several villages, a continent or several
A.
continents, or islands or several islands.
A.
It's
A.
A.
A,
A.
definitely.
A.
A, okay. To decide who would
Let's
be the
go.
next To decide who would be the next cacique, the Lucayans would allow the strongest males to participate in a spear fighting competition.
That's
True.
false, right?
False.
I wish so. That would have been.
True or
Cool.
false?
False.
False.
False?
False.
Uh,
Wait, Miss Petit Man, help us out on this one.
True or false? Which one?
No, don't let.
Was
You
it
can't
true
fool
or
me.
false?
True or
False.
false? Which one?
Okay, no, false,
Be
false.
cool
We're
though.
sticking with false.
False.
Alright, false is correct. So the
Oh,
position of the cacique was hereditary. That means that it passed on from what?
The son.
one.
Father to son, yes. Okay. And if there wasn't no father, it would go to the eldest son.
Cousin.
Okay, the eldest son of the cacique's eldest sister. So if there's no son for if the cacique didn't have no son or the son died or whatever the case may be, it would go to the his sister, and if his sister had a son, then that person would be the cacique. Okay, so oh my goodness, I gave you all the oh my goodness, I gave why did I do
The oldest son is the
that?
cousin. Eldest sister.
In the absence in the
A.
absence of a direct heir
Hey,
to the cacique's
Wow, Miss
position.
Super T.
Ah
guys,
A.
we
boy.
All
needed
the
that.
way.
We needed. See how we
Wow.
think again going wrong. We needed
Yeah.
that.
Alright.
Well,
Thanks.
me
That is
tested
false.
today. Well, thank
Ghana,
God.
that is false. So
Alright.
And
So
no missing because we're on one A.
you said B? You said B just now?
no, we say
No,
A.
no, no.
C.
A.
C.
A.
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 Alright,
A.
A.
Miss Petit.
Alright, confirm A. Alright. Okay, what is the name of a female cacique who ruled Western Hispaniola after the death of her brother?
D.
D?
I got this, girl. I got this.
You said
D.
you
Okay, we
said
win.
D?
Yeah.
D?
Yes,
Okay,
D.
D. We went with D.
D is correct.
Yeah.
Ah,
Okay.
yeah.
Very good.
I know that I'm
Anacona, right? Alright, Lucayan society was blank. This means that power, privilege, and responsibilities were different depending on your position in society. Is it A, linear, B, hierarchical, C, dynamic, or D, antisocial?
With her yak. Yo.
B.
Yeah, that's
It's
I know
B.
it too.
And it's like something about like inheritance, like you inherited.
Okay, let's go with B. B, Mr.
B.
Like
B.
B.
Yeah.
You wanna go with
B.
B? You go with B. Okay,
I
so
don't
we're
even
locking
know
in.
what word it is.
Do I used to that?
What the meaning of that
I
word
think
is?
B would
A
include
B.
You gotta follow the
inherited,
hierarchy.
so it might be B.
B.
B?
Yeah,
All
we're
right,
gonna try B.
you can try B.
I think
Yes, it's
yes.
B because
Yeah.
hierarchical just means that there's different levels. All right, so you follow a hierarchy. You
Oh,
follow,
right.
The way
yeah,
I guess the answers by how the words them look.
yeah, and because remember they used to do it by the air. You know what I mean?
Let's
Like
be dead
who's the
easy and
next
see how the
one?
words them look.
Yeah. Okay. Anyway, number 7. Under the cacique were blank, and below them were the ordinary Lucayans.
I got it. I got it.
Okay.
A.
What
Under
is
the
it?
cacique, under the
B.
cacique were the blank and the blank.
B.
No,
B.
why? Um,
B or B,
Don't
C,
second guess yourself.
B, C or D?
B
Which
or
one?
C?
B.
I
B or
choose
C?
A.
B,
I know what y'all, but I choose A.
B. I'm
B,
trusting I'll go myself. with B.
I
Yeah.
agree with
I
him.
think it's
B.
B. I think it's B.
B. All right, he said B. B is correct.
See?
All
You
right,
see?
so underneath,
See?
Oh,
That's
I
why.
under,
was.
Nice.
under the caciques were the
I thought I
nobles
was
and the
wrong.
priests. All right, next. The cacique was also the chief priest. True or false?
True.
True. That's
True.
True.
Most. Yeah.
True. The other Lucayans did not have to obey the cacique without question.
False.
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 False. Which are the rules of the cacique? Is it A, sharing out land, B, deciding on war,
E.
deciding on
All of
fixed
the
days,
above.
leading out
E.
ceremonies?
All of your
All
above,
above.
All of the above.
sir.
Very
All of
good.
the above.
Which is not one of the privileges of the cacique? Giving food, large house built for them, marrying all the women
C.
in the community,
C.
had more ornaments. So what are we going with?
I'd
C.
say C.
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 Let's say we go with C.
So he can't marry all the women in the community? No, he couldn't. All right. All
That
Oh
right.
my
makes
god.
sense.
All
I
right.
swear.
He could have several wives, but he cannot have.
Yeah, but a bunch of children, Mr. Petit.
Yes, sir.
Hmm.
All right. We y'all okay? Y'all got any wrong yet?
No,
Lord, it's
sir.
gonna be
We're trying to
faster.
get
No,
it.
sir.
So far we
We're
good.
good.
Like 100.
All right. What is
It's
the
B,
y'all?
right?
Okay. What is the name
B.
of the throne the cacique sat on?
B.
C.
C.
C. C.
C.
Oh no, no, no.
I thought it was B.
I think it's C.
Because
You said C. We gonna go with
flip.
C.
No, no, no.
No. I think it's B.
Wait, wait,
We
wait,
gonna,
wait.
what are we gonna go with?
Um,
You're gonna go with B. All right. That's correct.
Oh,
Two
thank
food.
God.
All right. So y'all got 100. So y'all did redeem yourself.
Yeah, we
No.
success.
we almost get one wrong. I think you spelled the T with that.
Yeah.
Right. All
I
right.
had to be scared for a second.
Okay. So let's move on to arcade. Okay. See how all our arcade time gone? Look at that.
Wow.
And anyway, let's continue on. This is Matthew chapter 2, and we're still talking about the Herod and the wise men story, and the visit of the wise men. Okay, so we are further down into this, and let's go. So Herod said, so the wise men came to Herod. They say, okay, we looking for you know the king of the Jews. They saw the star. The star wasn't really a star. It was a company of, anyone can remember?
Angels?
It was a company of angels, yes. A distant company of angels. The angels directed them to the place where Jesus was born. They gave Jesus the gifts. What were the name of the gifts?
Gold, myrrh,
Gold,
myrrh,
frankincense, and myrrh.
Myrrh.
Okay.
Myrrh. Oh, myrrh.
Yeah, myrrh. And so after that, they left Jesus. Now, Herod did ask them to do something in particular. Herod says, when you find a child, tell me, because I want to do what?
Worship him.
Worship him.
I want to worship him, right? But did the wise men listen to Herod?
No.
No.
No. So let's see what they actually did after they went to Jesus and what happened after that. So we're gonna start off with, I want Kennedy to read 11 and 12 for me.
And when they were come into the house, they saw the young child with Mary his mother, and fell down and worshipped him. And when they had opened their treasures, they presented unto him gifts, gold and frankincense and myrrh.
Very
And
good.
being warned of God, and being warned of God in a dream that they were not should not return to Herod, they departed into their own countries another way.
Another way. So what happened that deterred their movement to Herod?
They was
A
warned in a
dream.
dream.
The dream.
Yeah, they were warned in the dream. So in a dream, God told them, hey, listen, Herod is trying to swindle you. Herod is trying to fool you. Go another way. And so they departed and they went another way. And they didn't even go back to Herod to say, hey Herod, we found the Messiah. They didn't go back and do that. They said, listen, let's go another way and hurry up, right?
So where they
So
going? What country?
they didn't say. They didn't say which country they went, but they went to their own country. Remember, they was from the east, but they went to it. They went to it another way, so they didn't pass the same way they went. They say, listen, let's go and make sure we're not even noticed by this guy. All right.
Oh, okay.
And so number, this is, I want Miss Cooper to read 13 and 14.
And when they were departed, behold, the angel of the Lord appeared to Joseph in a dream, saying, Arise, and take the young child and his mother, and flee into Egypt, and be thou there until I bring thee word. For Herod will seek the young child to destroy him. When he arose, he took the young child and his mother by night, and departed into Egypt.
Departed into Egypt. So why did Joseph depart from where they was to Egypt?
Because the angel of the Lord came to
After
him
the
and
angel
told
came
him
to him,
to flee because Pharaoh wanted to kill
Not Pharaoh.
uh Herod.
Herod. Yeah.
Herod wanted to destroy him.
Herod wanted to kill the child. Now, why did Herod want to kill baby Jesus?
He wanted to be the only
he didn't want no other king.
no
Yeah,
other
he didn't want
king.
no other king. Exactly. He didn't want no other king. Um, and so does that happen in real life though? Like, what I mean is, have you ever been in a situation where someone tried to put you down because they knew if if you came up that you would be better than them? Ever happened to you?
Um,
Or if that ever happened to someone?
Yes.
yeah,
Yeah.
something like
So,
that.
Yeah,
Yes,
right.
so.
And so it's the same thing with Herod. Herod was trying to kill Jesus before he was even born. Okay, not before not before he even matured. Okay, and grew older. All right, this is for, I want Deshaun to read 14 and 15. Is Deshaun out? Or he left already? Okay, Hestiny, 14 and 15, please.
He left.
Okay. When he arose, he took the young child and his mother by night, and departed into Egypt, and was there until the death of Herod, that it might be fulfilled which was spoken of the Lord by the prophet, saying, Out of Egypt have I called my son.
Very good. So this thing, sorry, let me ask a question. At what time of day did they escape to go to Egypt? At what time of day did
By
they
night?
escape? By
In
night,
the night?
in the nighttime, right? Now, this thing that happened with them escaping to Egypt, it says that it's a part of a prophecy. So before Jesus even born, the prophecy was already out that, hey, listen, um, someone's gonna be out seeking the life of Jesus, and I'm gonna have to call him of um out where he is to flee into Egypt. Okay, and so that was as a prophecy already prophesied in the Bible before Jesus even born, that he's gonna have to make the move to flee. Now, so some time passed on, and then Herod realized that, hey, I wonder where these wise men is, and so we're gonna pick up on verse 16 and 17. Any volunteers to read 16 and 17?
Me.
Who hasn't read before? Who hasn't read before? Who hasn't read? Who has not read before? No one?
I read it.
Then Herod, when he saw
Wait,
that
who
he
is
was
this? Who is this speaking?
Zaria.
Okay, Zaria. Okay, go ahead. 16 and 17.
Then Herod, when he saw that he was mocked of the wise men, was exceeding wroth, and set forth and slew all the children that were in Bethlehem, and in all the coasts thereof, from 2 years old and under, according to the time which he had diligently inquired of the wise men. Then was ful- then was fulfilled that which was spoken by Jeremiah the prophet, saying,
Okay, good. So, can someone tell me or describe what was Herod's reaction when he realized that the wise men didn't come? What was his reaction?
Anger.
He was mad.
Angry.
He was
Angry, right?
angry.
Yeah, that's what it says. Exceeding wrath. Like he was very angry, right? Exceeding wrath, right? Okay. He was so angry that he did something that is ludicrous, something that is so terrible. What did he end up declaring or decreeing that would happen?
Murder all the boys
To
and the
nurture all the boys.
That's something, eh? Wow. All the
2 years.
boys 2 years and under. I mean, someone would go that length just to stop one king, right? One puny little child. You'd go that length to stop that child. Herod was really obsessed with power.
it giving Moses vibes. Like
I
Moses.
just was gonna ask if
Yeah,
this have something to do when Moses was like when they had to put him in the river and the basket and all of that.
it's a similar story, but this happened years, thousands of years after Moses' time, right? Moses' time was in that was in the Old Testament. Right, this time we're in the New Testament, and the same thing happened, right? And it's really the devil working through these kings, because the first time, um, and that's why Moses is a we say that Moses is he was similar to Christ in some ways, because just like how Christ um just like how Christ had to flee to Egypt not to get killed, Moses had to leave where he was. His mommy had to put him in a basket to flee from being killed. And just like how in the time of Jesus, where they killed all the boys, right? It's the same thing with Moses. They killed all the boys of a certain age, all right, of a certain age group. And so they are similar stories. And so I like that you brought that up. Um, you know, but it's amazing. Like you can imagine how much crying was in the country They just go inside, knock your door open, and just take your brother who is 2 years old or younger than 2 years old. And the thing is, they ain't even, I don't even think they really calculated the age. They just look and say, okay, well, he look like 2 years old. And they just pull up and slay him, right? And so you can imagine how
I
much.
think everyone
Well,
has
but
that.
see, Aunt Heather had a baby son too.
Say it again?
Aunt Heather had a son too.
Yeah, he had a son, but his son was in 2 years, right? And even if the son was 2 years, he still wasn't going to kill his son. No, he wasn't going to kill his son. But yeah, that's a lot of crying, right? There's a lot of crying. Um, crying, sisters crying, brothers crying, mother crying. And so verse 18 really helps us to put into context what's happening here. Who's going to read? Who hasn't read before? Someone who has not read before. Okay, I have to start calling names now. Okay. Who's here? Someone left. I guess they don't wanna. They don't wanna. They want me to call them. I want. Who I want to read? Joseph Brathwaite, are you here? And alive and well. Joseph is not here. Okay, who is here? Um, Sean. No, Avernick. Avernick, can you read for us? I hope you don't mind reading this. Avernick.
I am.
Okay, good, good. So read verse 18 and 19 for me, please.
In Ramah, there was a voice heard, admonition and weeping and great mourning. Rachel, Rachel weeping for her children, and would not be comforted because they are not. You want me to read 19 too?
Yeah,
But when Herod was dead, behold, an angel of the Lord appeared in a dream to Joseph in Egypt.
good. So this was a prophecy spoken by who? Who prophesied that there would be a lot of crying and a lot of weeping? Who prophesied that? What's the name of the prophet?
You
Jeremiah.
give us a hint?
What would you say, Sister J?
Jeremiah.
Oh, okay, Jeremiah, right?
Yeah, cool.
Jeremiah is the prophet that prophesied, saying that hey, um, there's gonna be a lot of weeping, there's gonna be a lot of crying, and that's what words. There's three words that tells us that there's gonna be a lot of crying that is used in the verse. Three words:
Lamentation is
lamentation,
good mourning,
yeah,
Mourning
mourning,
lamentation,
weeping,
weeping,
and weeping.
and
and great mourning.
mourning. Yes, all those things mean crying and sadness, right? Now it says Rachel weeping for her children. Now Rachel was Jacob's wife, one of Jacob's wife. Anyone know who was another one of Jacob's wife?
Wait, did a divorce or something, or you just had two?
He had two. He had two. And he
Gee.
had more, but the main two.
You said a me too.
Yeah, the main two. The first two. Let's say the first two. Or let's stick with main
Rachel,
two. Rachel was one of the main two, and then her sister. What's the name of her sister?
Isabel?
Not Elizabeth.
I
so
say Isabel.
Uh, anyone else?
he was married to two sisters.
Yeah, he's married to two sisters. Yeah, he actually wanted to marry Rachel first, but he got swindled. The father of the two sisters swindled him and caused him to marry the eldest first, and he didn't like the eldest. He really didn't like the eldest, and so
Well, he was forced to marry her.
yeah, he got swing. At the wedding,
That's sad.
yeah, at the wedding, she didn't show her face, and he thought that he was marrying Rachel. He ended up marrying Leah.
Oh
right?
wow. Oh yeah, Leo.
Leo, Leo,
Oh yeah.
Leo.
I
Okay,
never had a man.
okay, Leo.
Sometimes we just want to
So,
stop the wedding.
all right. So it says Rachel weeping for her children, and here Rachel, they just using Rachel as a symbolism for all of the women. So they're saying that when the prophet Jeremiah wrote this, he was talking about not Rachel specifically, but he's talking about the fact that there's going to be a lot of crying because of the death of these children. But I think that's very cruel, don't you think? I think that's very cruel what Herod did. You
And
think it's
they're
actually
22 years and under, like they so young.
yeah, they're very young, right?
Eh,
So
so
All of them be going to heaven because I bet they
somewhat
didn't do nothing.
cruel, I guess.
Yeah.
it's definitely cruel, Mr. Bethel. I mean, there's no
Back
They
then they
ain't
had
do
like
nothing
like
wrong, so
20 children and thing.
say it again.
I say back then they used to have plenty children. They used to breed like crazy.
But it still isn't right to kill one. I mean, you know,
yeah, and that's
it's
sad
like
because all them died just for
yeah, it's sad.
him not.
Just for
And
him.
if some of them
It's
was
like they
die
ain't
off
do nothing
anyhow.
wrong, so it's like it's very hard.
Yeah, I with you, Hestiny. Hestiny of a heart. Like,
A
I
lot of
mean,
them die anyway.
the fact that they die doesn't make it right to kill them. I mean, it's like
I know,
saying,
right?
He
yeah.
agreeing with Harry.
Anyway, let's read
I
number
know why
19.
racism means
Breed
stop
make your
doing that.
value difference.
In Miss Petit,
Um,
why racism means stop them from doing
say it again.
them from
Say it
doing
again.
that.
Uh, no, the angel didn't. No, they didn't at this time.
Well,
So
if they wanted their child to live, they would have bribed the gods.
anyway, 19 and
Did
20.
they even know
Miss
in the
Cooper,
city?
go ahead. If they knew,
Like, did they even have time to like prepare, or they just going around killing the children?
I don't think it was a preparation thing. I think it's just like they go and they
So they
start
couldn't
slaying.
they
You
couldn't
know they
plead or nothing if they didn't know.
yeah
I'm
unless
sure they have sip sips. Some families
yeah,
have sip
yeah
sips.
of course you would have sips and then you would try to eventually try. I mean certainly some people escape now. I mean but the vast majority did
That
not.
baby is been under a dirty blanket.
All right, Miss Cooper, 19 and 20.
But when Herod was there, behold, an angel of the Lord appearing in a dream to Joseph in Egypt, saying, Arise and take the young child and his mother, and go into the land of Israel, for they are dead which sought the young child's life.
Yes. So after Herod had died, so the good news is um that the person who was trying to slay baby Jesus, um that whole conflict subsided when Herod died, and so the the angel basically told Joseph, okay, the coast is clear, all right, the coast is clear, everything is settled now. You can go back to Israel because Herod is dead, and at
So,
least for
Mr.
a
Repeat.
time. Yes, mom.
So, like, before they start talking about the Pharaoh trying to kill a baby, didn't they, like, go on before that?
Who?
When he told Joseph to carry his wife, the baby and her to somewhere, like, didn't that happen before Pharaoh mentioned killing the babies?
Yeah, Herod, you mean? So
Yeah,
yeah, it happened.
he's
So
saying.
of course, Joseph was given the warning before the decree went forth, right? And that would make sense because he had to escape, and so after he escaped, then the decree went forth to kill all the children, and then Herod ended up dying, and then the angels say, okay, you could go back now because Herod is dead. Okay. And so I'll read number 22 and 20. So I'll read number 21 to 23, and we're gonna end there. It says, "And he arose and took the young child and his mother and came into the land of Israel. But when he heard that Archelaus did reign in Judea in the room of his father Herod, he was afraid to go thither. Notwithstanding, being warned of God in a dream, he turned aside into the parts of Galilee. And he came and dwelt in the city called Nazareth, that it might be fulfilled which was spoken by the prophets, he shall be called a Nazarene." And so Jesus spent his life growing and living up in the city of
Nazareth.
Nazareth. Nazareth.
Nazareth.
Right? Yeah. And so
Nazarene.
So
and
what
so
happened to the Herodias?
which one? The first one or the second one?
The one who wanted to kill
The one who
John.
wanted to kill the one who wanted to kill John. Um you mean the one who wanted to kill John? You mean the one who gets killed Jesus, right? That's right.
No,
No,
King
John.
Harriet.
No, remember I trying to figure which one you're talking about because
You
this
know
one,
John the Baptist?
yeah, I know John the Baptist, right?
Yeah, the one who
Um,
wanted him dead.
you ain't talking about the one with who wanted Jesus dead.
No, no, the one who wanted John the Baptist dead.
Who wanted, I don't know. I don't know what happened to Herod. I know that there was a Herod who ended up turning into worms, but I don't know if that was the Herod um who was looking after John, who was trying to kill John. I can't tell you if that was the father or the son. Okay, but I know one
Okay.
of the Herods. I know
And I
one of
had
the Herods.
one more question.
Go ahead.
You don't think it's unfair that prophets exist?
That's a nice JPR question. Is it fair? Is it fair? That's a nice
Because if you think
JPR.
about it, if the prophet,
Uh-huh.
whatever the prophet speak, gotta come through the person who they speaking about, they ain't got no choice.
Um. Okay. That's not true about prophecy. Let me give you a prime example. Remember the prophecy about remember the prophet named Jonah, right? And so Jonah was told by God that hey go and warn Nineveh. Go and tell them that how much days they have. And you remember? 40 days they have.
40.
And else their city will be destroyed. Now, when it comes to prophets and prophecies, right? There's something called a conditional prophecy. So when the conditional prophecy come, it's under a condition. So in the case of Jonah, it's that okay, if you don't get things together in 40 days, your city will be destroyed. But what they end up doing is that they end up praying, repenting, and and then um, within 40 days, their city was not destroyed. And Jonah was kind of mad. Jonah was like, "Man, come on, God, like now the people look at me like I's a false prophet. They think I, you know, they they don't trust my words, right?" And he said, "Man, I know you's gonna spare them. I know you's gonna have mercy on them." The thing is that um prophecies usually come with a condition that hey, if you apply by this, then here's the result. But if you don't apply by this, then here is the result. And so there's no force to say that okay, it will happen this way, right? It's that if you do this and you continue to go do this, then of course the judgments of God is going to come upon you. But if you do what is right, then of course the judgments of God is not going to come upon you. And so that's the idea when it comes to um, prophecy. So I wouldn't say it's entirely fair. I wouldn't make that case. Um, that's my stance on it.
All right, all right.
Yeah. Okay, so it's 9:03. And so I want to say goodnight to you all, warriors. You endured all through up until the very last lesson. and up until the very last minute. So I want to thank you so much for doing that, especially those who were participating. You made it happen. You kept it engaging and everything, so I appreciate that. We begin week 5. Woo, week 5.
Already?
Yeah, week
That was
5.
quick.
Yeah, we begin week 5.
Yes. A little bit too fast.
For real?
Yeah. Adrian Suzuki, I'm so glad that you spoke. Can you send me some notes, please? Because I'm not getting any notes from you. Right? Adrian Suzuki. All right. So, yeah, this week 5 is next week, right? And
Ha.
so, go ahead, sir. He's going to say something.
I was speaking the whole time we was talking about Lukai, so you didn't even see me.
No, I didn't. This is the first time I'm actually looking at the thing to actually see it's you. But yeah, man, send me some notes. I haven't received anything from you, Mr. Adrian. You have my number?
Yes, sir.
Okay, good. Send those notes for me, please.
Mr. Petit, you don't sound like Kennedy.
No, he does not. Anyway, have a
How
good
dare
night,
you?
everyone.
They
Have a
sound
good
a
night.
lot to me.
Have a good night, everyone.
Everyone in this song, like,
See you later.
And I'll see you.
Bye.
I'll see you on next week.
I
Have a
can't
good
tell the
night.
genders apart.
It's that stage, man. It's that stage. They get developed, you know.
All right, good night.
Good night. Good night. That's so funny. All right. Have a good night, everyone. And good night, special good night to Destiny.
Oh, wow. Good night.
Good night. All right.
I actually